So now we're going to move on to part B. So for part B, we want to find an equation for C. So we want to find an equation of our circle C. So I'll scroll down a bit so I can write down here. So for part B, the first thing I'm going to do is to actually write down the form of a circle equation. So that's going to be x minus a squared plus y minus b squared equals r squared. So this is the standard way to express the equation of a circle, where AB is the center of the circle, and R is the radius. So in this question, we do have the center of our circle, so that's 7, 5. So that just means 7 will be A and 5 will be our B. So if we can substitute those values in, we can rewrite this again as x minus 7 squared plus y minus 5 all squared equals r squared. Okay, so what remains is for us to find out what r is. Now, since we have our center, what would be useful is if we could find exactly what coordinate P is. If we can do that, then we can use these two coordinates of P and A to find this distance here, which corresponds to the radius of the circle. And so once we find that, then we have our value to substitute into our equation here, and then that will give us the equation for C. So then what we have to figure out is, okay, how do we find the point P? Well, we know the equation of line L that's given to us here. It's y equals 2x plus 1. And then for part A, we actually showed that the equation of line PA is this. It's 2y plus x equals 17. So if we could perhaps find the point of intersection between those two lines, we can then find what point P is, and then we can go from there. So let's try finding the point of intersection between L and PA. So here we're going to find the point of intersection between L and PA. So the best way to do that is to substitute the equation for L into the equation for PA, or vice versa. So the equation for L, that's y equals 2x plus 1. That's for L. And then for PA, it's 2y plus x equals 17. So if this is 1 and this is 2, we could just sub 1 into 2. So let's have a go at that. So y equals 2x plus 1 substituted into 2y plus x equals 17. That's going to be 2x plus 1 times 2 plus x equals 17. So let's solve this algebraic equation now. So multiplying each term by 2, we get 4x plus 2 plus x equals 17. Then we get 5x plus 2 equals 17. We just scroll down, so 5x equals 17 minus 2. That's just 15, and therefore x equals 15 over 5, which is just going to be 3. So our x coordinate for our point P is 3. And now all we need to do is find the corresponding y coordinate. So we're going to take x equals 3 and substitute it into either equation. L or PA. I'll just substitute it into L because it just seems a bit easier to do that. So substitute X value back into one of your equations. So Y equals, I'll just write in this example using L. So then Y equals 2 times 3 plus 1, which is 6 plus 1, so that's 7. Okay, so therefore the coordinate of point P is 3, 7. And our coordinates for C, 5, 7, 5. Let's just double check that. Yeah, 7, 5. Okay, so now what we can do is we can find the distance between these two coordinates, and that's going to give us the value of the radius. So then we just use the equation that we learn to find the distance between two coordinates. So it's going to be D equals x2 minus x1 all squared plus y2 minus y1 all squared, square rooted. So all we need to do is substitute in our values by first choosing what's our first coordinate, what's our second coordinate. So then we can assign values of x1, y1, for example, if point P is our first coordinate, and then assign values of x2 and y2 for C if we choose that to be our second coordinate. So that's what we're going to do. We're going to choose, this is our first coordinate. So that's x1 and that's y1. And then if this is our second coordinate, then 7 is our x2. I'll do a different color there, x2, y2. So let's just substitute those values in. So D equals root of x2, so that's 7 minus 3 all squared plus y2, which is 5 minus 7. Okay, so we can do it like that. Ultimately, it doesn't actually matter which order we do it in, but it's nice to get into the habit of labeling your coordinates and the values you're using for each variable. So D equals root of 7 minus 3, so that's 4 squared, plus 5 minus 7, that's minus 2 all squared. So you can see, because we're squaring each value, both of these values are going to be positive no matter which order we take them away from each other. So D is root of 16 plus 4. So that's going to be D equals root 20. We can simplify that a little bit. Root 20 is root 4 times root 5, which is 2 root 5. So in fact, the distance, which is equivalent to the radius r, is 2 root 5. And so if we want r squared, that's equal to just 20. And that's what we want to substitute into our equation up here. So then we know our final answer to this is going to be x minus 7 all squared plus y minus 5 all squared equals 20. And that's the equation of circle C. So we've done part